Polygons. If you're clicking on this link, then you want to know exactly what a polygon is and the difference between a regular and irregular polygon. But more importantly than that, the toughest task of today's learning is to know how to calculate the sum of all the interior angles of any polygon. So I could randomly give you a 12-sided shape, and you need to be able to calculate, without using a protractor, the total of all of the inside interior angles. Quick warm-up. We need to remember which polygons are which and how many sides they have. Can you, in your mind, just quickly match up the shape with the name and how many sides it's got? Well, the first one's easy. A triangle, 3-sided shape. The heptagon has a 7-sided shape. The pentagon, 5 sides. Hexagon, 6. Octagon, 8. Quadrilateral, any 4-sided shape. Not just a rectangle, any 4-sided shape is a quadrilateral. Pentagon, 5. Quadrilateral, 4. Heptagon, 7. Triangle, obviously 3. Hexagon, 6. Octagon, like octopus, 8 sides or 8 legs. We should all know or remember that if we add up all 3 angles inside a triangle, the total of the angles will always be 180 degrees. And that's irrelevant of what the 3 angles measure to be independently. We do not even know what the sizes of angles X, Y and Z are. But we know that if we add the 3 of them together, we must get 180 degrees. Likewise, the interior angles A, B, C, D always add up, of a quadrilateral rather, always add up to 360 degrees. That's irrelevant of what A, B, C and D are independently. Let's take this quadrilateral. Let's just pick any corner at random. I'm going to choose the top corner and I'm going to join it up with other corners that are available by drawing diagonals. I can't join this corner up to here because that's an edge, same as this corner, but this corner is available. So I've joined it up using a diagonal. There are no more corners available. Now this quadrilateral has just simply been transformed, if you like, into 2 triangles. What do the angles of a triangle add up to? 180. So these 3 red angles add up to 180 degrees. Likewise, if we add up the 3 green angles, we've got another 180 degrees. So the interior angles of this triangle is 180, and the interior angles of this triangle is 180. So if we add up all of the interior angles, including the ones that are next to each other, we should get 2 lots of 180 added together, which, as you will know, is 360 degrees. Let's take the pentagon. We know it's a pentagon because there are 1, 2, 3, 4, 5 sides. Take any vertex or corner that you like. I'm going to choose the bottom one and join it up with diagonals to any other available vertex. This corner is an edge, is joined with an edge, so you can't draw a diagonal here. Likewise with this corner. However, this corner and this corner are available to draw diagonals to the to join up the corner that we're starting from. This pentagon has now been divided into 3 triangles that are next to each other, that are joined together. The 3 red angles of a triangle add up to 180, as do the 3 green angles of the triangle. And of course, don't forget the 3 brown angles of the third and remaining triangle. So we've got 3 triangles, 3 180 degrees, total interior angles. So like before, the total interior angles of the whole shape, the whole pentagon, is all of the angles added together, or all 3 sets of 180 added together, which you should be able to calculate to 540 degrees. 1, 2, 3, 4, 5, 6, 7 sides. The exam question that you may be asked is work out the sum of the interior angles of a heptagon, a 7-sided shape. Again, we will choose our vertex and draw diagonals to all the other available vertices. And then we're going to count how many triangles we've got. If you could make a quick sketch of this heptagon, pick a corner, any corner you like. I'm happening to be choosing the bottom one again, and join up to all the other corners or vertices that are available. This corner's on an edge, they share an edge, so it's not available. Likewise with this corner. However, this vertex, this corner and this corner are all available. 4 diagonals and 1, 2, 3, 4, 5 triangles. We have split up our heptagon into 5 triangles. So the sum of the interior angles of the heptagon is simply 5 triangles times 180 degrees for each. What is 5 times 180? 900 degrees. So all of the 5 triangles contain a total of 180 degrees. There are 5 of them, so you need to multiply 5 times 180. The interior angle of any heptagon, any 7-sided closed shape, is 900 degrees always, regardless of how big each interior angle happens to be. They will always add to 900. And we can actually form a table to show the sum of interior angles of any sided shape. Copy and complete this table. Press pause whilst you do so. Thank you. You've copied the table. We're going to complete this together. The first column is how many diagonals we'll draw from one corner, one vertex. Remember the triangle, the 3-sided shape, remember n is the number of sides, we didn't draw a diagonal. There was no points available. The quadrilateral, we drew 1 diagonal. The pentagon, we drew 2 diagonals. The heptagon, we drew 4 diagonals. Between 2 and 4, I'd expect to see 3. 3 diagonals for a hexagon. And you'll see a pattern as so. The number of triangles formed, well, that happened to be, with a triangle, there was just 1 triangle, full stop. The quadrilateral was split into 2 triangles. The pentagon 3, the heptagon was split into 5 triangles. The hexagon must be between 3 and 5, 4 triangles. You can spot a pattern. The number of diagonals goes up by 1, the number of triangles goes up by 1. And the number of triangles is almost 1 more than the number of diagonals. Or if you like, 2 less than the number of sides. The sum of the interior angles, triangle 180. Quadrilateral was 2 180s, which is 360. The pentagon was 3 lots of 180, 540. The heptagon is 5 lots of 180, 900. So the hexagon, with 3 diagonals we could draw, 4 triangles formed, 4 lots of 180, the sum of the interior for the hexagon is 720. We can use these relationships to derive a formula, an expression for n, for an expression with n for calculating the sum of interior angles of any sided shape. A shape could have n equals 100 sides, 1,000 sides, and once we've got a formula, you can work out how large the sum of the interior angles will be for any sided shape without even having to draw the shape and the diagonals. Well, first of all, the number of diagonals. That is always 3 less the number of sides, n minus 3. The number of triangles is always 2 less than the number of sides, n minus 2. And once you've got your number of triangles, n minus 2, what do you multiply the number of triangles by? 180. So the formula is 180 times by whatever n minus 2 may be. So we simply said we can have any number of sides in the shape. I'm going to pretend that I've got a 102-sided shape. N's 102. The number of triangles formed will be 102 minus 2, 100. The sum of the interior angles is 180 times by that 100, which is 1,800, 18,000 degrees. A 102-sided shape has a sum of interior angles of 18,000 degrees. I did that in my head without even having to draw the shape or worry about drawing the diagonals. This is easily a C or B grade question. Possibly, if it's a C grade, it's a very difficult C grade. We're going to use our angle rules, interior angle rules, and our skills of algebra to find out exactly how many degrees x is. If we've got 4 angles in a quadrilateral, we know angle J, 127, the blue angle, KJE I should really call it, the blue angle is 88. Whatever x is, the green angle is 5 times x plus 3, and the orange angle is 10 times x plus 7. Now, we've got x twice, but we don't really know how to calculate it unless we use the sum of interior angles rule. What do the sum of interior angles of a quadrilateral add up to? You should have the table in your notes, or from memory, 360 degrees. So I could simply say, let's add up all 4 of these angles and make it equal to 360 degrees. So we've got the brown angle, the orange angle rather, plus the red angle, plus the green angle, plus the blue angle equals 360. Algebra time. Letters on the left, numbers on the right, and numbers to go over to the right. Well, first of all, how many x's have we got? 10 plus 5, 15 x's. How much should go over to the right? 7 plus 127, 134, plus 3, 137, plus 88. Well, plus 90 would be 227, minus 2, 225. So the left-hand side of the equation is simplified, or tidied up, to 15x plus 225. The right-hand side is 360. The aim is to find out what x is, i.e. to get x on its own. So we need to get rid of everything else from the left to the right. The first thing we need to get rid of is this 225. If I have 225 and I want to get rid of it, I just simply take it away. But don't just take it away from the left side, take it away from the right as well to keep the equation balanced. We'll subtract 225 from both sides to keep it balanced. There we go. Now 225 minus 225 simply becomes 0. So this bit vanishes and you're just simply left with 15x on the left. On the right, what is 360 minus 225? A few seconds to calculate that. 135. So the right hand side's 135. 15 x's gives you 135. So basically, how much does 1x give you? To get x on its own, we need to get rid of the 15. In algebra, numbers and letters next to each other means multiply. The opposite of multiply is divide. But remember, don't just divide by 15 on the left. Keep it balanced. Do exactly the same to the right. Divide both sides by 15. 15 divided by 15 is simply 1. One lot of x. So this bit vanishes. You're just left with x. How many 15s go into 135? Well, I know that 10 15s are 150, and 1 15 less is 135. 1 less than 10? 9. So x is simply 9 degrees. You might be asked to calculate the size of the green angle. Well, 5 times 9 is 45, plus 3 is 48. You might be asked to work out the size of the orange angle. 10 times 9 is 90, plus 7 is 97. You may want to check that these values are correct. 97 plus 48 plus 127 plus 88. Does that equal 360? I'll let you decide.
Can you work these out?
Pause the screen here. I apologise that the font is quite small. After you've paused, you will calculate the sum of interior angles of each of these shapes. Some of these you might be able to get from memory. Remember, use the formula 180 times the number of sides minus 2, i.e. 180 times 22. When you're ready, unpause. An extension question. Here we've got 1, 2, 3, 4, 5, 6 sides of a polygon, i.e. hexagon. And your job is to calculate the size of angle x. This is extremely similar to the example that we've just gone through. First of all, using your table or memory, what is the sum of the interior angles of a hexagon? Remember, a hexagon has 6 sides. The number of triangles is always 2 less. 2 less than 6 is 4. The sum of interior is 180 times those triangles. 180 times 4. 720 degrees. So if we sum up all of these angles, we should get a total of 720 degrees. Write down this expression. The brown angle, or I should say the beige angle, plus the red, plus the pink, plus the green, plus the blue, plus the, I've covered the pink, plus the brown, gives you 720 degrees. Can you collect like terms on the left, or simplify the left, I should say? Remember, how many x's are there in total? And how many numbers there are in total? Click pause if you want a few more seconds to do so. Right, 5x plus 3x is 8x plus 4x, 12x. 160 plus 30 is 190. Plus 20 is 210. Plus 60 is 270. Plus 100 is 370. Plus 130 is 500. So the left should become 12x plus 500 equals 720. Remember, we want to find out x, so we want to get rid of everything else around x to the left hand side, to the right hand side rather. Start with the most distance away. 500 is further away visually than 12. Let's get rid of 500. The opposite of plus is take away. But remember, Take 500 from both sides. Copy down this new expression and see if you can write the next line to simplify this expression. Press pause if you want a few seconds to do so. 500 minus 500 is nothing, so this bit vanishes. You're left with 12x. 720 minus 500 is 220. That's 12 x's, but simply, what's 1x worth? Remember, a number times a letter can be written without the times sign. You know they're multiplied, so do the opposite of multiply to get rid of the 12 on the other side. Divide it, but not just one side, divide both sides by 12. Well, 12 divided by 12 is just 1. One lot of x, the numbers vanish. What is 220 divided by 12? Press pause to calculate it in mentally or use a calculator here. The numbers are a bit awkward. 18.33 recurring. X is 18 and 1/3 of a degree. Ignore the date of this worksheet, but here's a difficult question for you. There are no solutions to this. This is an A-grade question, really. You've got a regular polygon with the number of sides, there are too many to count. But you do know that the sum of the interior angles is 9,000. Using the formula, how many sides will this shape have without you having to draw it and count it? Remember, 180 times the number of triangles, or 2 from the number of sides, gives you 9,000. Rearrange the equation to find n.